Okay, so number 10, a little bit weird, right? Because what are we missing in our function here? We're missing x, right? We don't have anywhere to plug in our x values. What are we looking to find out of this table? We know what our x values are, but what are we looking to find? Our y values, right? That's what we're doing for all these problems, is we're trying to figure out what the y value is equal to. I don't see anywhere to plug in x, but do I know what y is equal to with this function? Yeah, what is y equal to? 6, right? So as weird as it seems, all of your y values are going to be 6. Okay, and your coordinate pairs here will be 2, 6, 3, 6, 4, and 5, 6. Let's describe this. Is this function linear? Oh, I hear some people saying no, some people saying yes. Why do you say no? Oh, why do you say yes? Because it's a straight line. Okay, I don't see a graph here though, so it's hard to tell. But okay, good. There's no exponents, right? It definitely would be a straight line. In fact, it'll be a horizontal line, right? So this is definitely going to be linear. Now, is it going to be proportional?
No.
Definitely not. That's non-proportional because our y-intercept here is 6.
Yes.
Right? All right, down to number 11. Now, number 11 was a lot more confusing than I was hoping it would be. Do we have a y-intercept here?
No.
No, we don't. So right away, we know that this is proportional, right? And I don't see any exponents here, so we also know that it's linear. Let's just get that out of the way. Now, what's our slope of this function? What's our slope? Negative 1 is our slope, right? We don't see a 1 there, but really this equation is y equals negative 1 times x. Right? We can't forget about that negative sign just because there's no number next to it. That's still a negative x. So just like before, you're going to take out x and replace it with parentheses, but everything around it gets brought down, including the negative sign in front. And that's what a lot of people that I saw may have been missing, was this negative sign in front. So we plug in a negative 4. And then another point of confusion happened where people thought that they were either subtracting 4 from 1 or subtracting 1 from 4. I saw a couple different things. But what do we have to do here with these two minus signs? We're going to turn into a positive, right? So really, this is just negative 4, which is positive 4. So our solution is going to be negative 4, 4. Let's do the same thing with the next one. We plug in negative 2, and what do we get? Positive 2, right? All we're doing is changing the sign of our number, but the number itself is staying the same. What about down here when we plug in positive 2? Now we get negative 2, and when we plug in positive 4, we get negative 4. That's right. Are any of those inputs repeating? No, they're all unique. Even though they're the same numbers and half are negative, half are positive, they're all different numbers. So this is definitely still a function. Questions on 11? Okay, let's look at 12, because 12 now we're getting a little bit different, right? Is this going to be linear or non-linear? There we go, beautiful. That's what I like to hear, non-linear. How do you know it's non-linear before we even find any points, Azalea? There's an exponent right here. That little 2 up at the top tells us this is not a straight line. Does anyone remember what the name of this shape is? Starts with a P. Hannah? Parabola, right? This is going to be a parabola. It looks like this. Not a straight line, right? We'll talk about that more on Monday. But again, we're going to take out our x, and we're going to replace it with parentheses. The plus 1's got to come down, and our exponent of 2 has to be brought down as well. We can't forget about that. We'll plug in -1. And what is -1 squared? Azalea, what's -1 squared?
-1 times -1.
That's right. -1 times itself, -1, which is going to give us +1. Plus 1 gives us 2. I saw a lot of people forgetting to do the +1 here as well. We got to evaluate the entire function. Right? And it's a +2 right there. Second one, y is equal to 0 squared plus 1. What's that going to be?
1.
1, that's right. 0 times 0 is 0. Plus 1 gives us 1. Now what's 1 squared? 1. Plus 1 gives us 2. And look at that, we have a repeating output. Is that okay?
Yeah.
Yeah, that's fine. We can have repeating outputs. We cannot have repeating inputs, right? Final one, y is equal to 2 squared plus 1. That gives us 4, right? 2 squared is 4.
Yeah. Plus 1.
Plus 1, that's right, gives us 5. There we go. So take a look at our y values here. We go from 2 to 1, back to 2, and then up to 5. Is that a constant change in y there?
No.
No, definitely not. We're subtracting 1, and then adding 1, and then adding 3. That's not a constant change at all. That also tells us this is non-linear.
Non-linear.
Is this going to be proportional or non-proportional?
Non-proportional.
Non-proportional. Let me ask you something. Can I have a function that is both non-linear and proportional?
No.
Why not?
Because,
Theo, how come?
I forgot the words. Hold up, I was
That's okay.
For to be proportional has to go through the ordinate and the linear.
There we go. All proportional relationships must be linear. So even on number 8, right? This is one that we had in the notes. So you could have just copied your notes down for this one. Even though we have a point at 0, 0, it is still non-proportional because it's not linear. It's not a straight line. Okay? Any questions about this worksheet?
No.
Very nice. Go ahead and hand it to whoever's in seat number 1 of your group. And